So nothing can escape, and that's a black hole.
It is over. Physics as we know it is on the verge of collapse, about to drown in an ocean of shattering discoveries that have risen from the deep abyss of the universe. Even the best of scientists can do nothing to stop this impending doom because the Webb Telescope has uncovered what we were never meant to see. The universe's hide-and-seek game is over because the JWST has uncovered its ancient secret at the bottom of a black hole. What's so special about this mysterious hole that is causing scientists to break into sweat? Could this hole be the portal to a parallel universe or a world of empty darkness? Join us in today's video as we uncover how the Webb Telescope found a hole in the universe where nothing exists. Our current cosmological models are at risk of extinction due to some breathtaking discoveries that the Webb Telescope is unearthing. The JWST is a product of years of research and billions of dollars, and a testament to scientists' desire to explore the uncharted depths of our world. The JWST came into the picture after scientists realized that we had been living in the dark regarding our understanding of the early universe. The early moments of our universe have been shrouded in mystery, as astronomers pondered how the world looked before the first stars and galaxies were birthed. Whenever we go down memory lane to replay the key moments of our universe since it was formed by the Big Bang, this period never shows up. It's like a blank slate with no words written on it. Although scientists have tried their best to solve this daunting question with several hypotheses, they have yet to reach a common ground and scale the high walls that this problem has built. However, it seems this problem won't last long, going by the Webb Telescope's recent discoveries. Like soldiers on a roll call, scientists have scrambled into action as they gaze into the new picture being painted by the JWST. A new theory is on the horizon, and it is being unveiled layer by layer with each discovery. The Webb Telescope has been our tour guide on this journey into the deep abyss of our universe's history, and its latest findings are inclining toward nothingness. This discovery of nothingness would not only spark a light in our understanding of the universe but might lead to the untimely death of current cosmological models. Scientists have longed for the day when they would fully understand the universe, with no part left untouched. Like a gazelle out in the wild, this lofty goal has eluded scientists despite all their efforts to have a theory of everything. As much as we tried, the universe resisted our moves, insisting on maintaining its air of mystery. It seemed there would never be light at the end of this tiring tunnel until scientists came up with the concept to develop the James Webb Space Telescope. The JWST was astronomers' knight in shining armor and was meant to be the game changer in infrared astronomy. It was scientists' ace card in taking scientific investigations in astronomy and cosmology to the next level. The task of developing this one-of-a-kind space telescope had to rest on a manufacturer that knew its onions and was the best in the game. Northrop Grumman Ball. Aerospace and technologies fit this bill, so it was entrusted with what was considered the project of the decade. When the JWST was finally completed and launched into space, it proved its detractors wrong and confirmed that it was the messiah that NASA and the other space agencies had been waiting for. In a matter of weeks, the Webb Telescope inherited the Hubble telescope's throne as the leading space telescope in the world. The Webb Telescope not only scaled the Hubble's hurdles, but also uncovered shattering discoveries that we never could imagine were lying in wait. The JWST could look at the first stars and the formation of the first galaxies, the same objects that were considered too distant for Hubble's scientific instruments. Thanks to the superpower of the JWST, the scales have fallen from our eyes. Although we don't have complete information yet, the knowledge that the Webb Telescope has brought back is more than enough to crack the walls and foundations of existing cosmological models. We have been able to uncover some of the first stars and see their properties. It is this last bit that has been a source of concern. The properties exhibited by these early stars and galaxies don't align with the picture we have created in our minds, nor do they fit into the box we constructed under the guidance of existing cosmological models. Our predictions about these stars have been shattered. These discoveries are rapidly writing a new history of our universe, such that scientists have been forced to tag them as universe breakers. The havoc created by the JWST in astronomy is widening with each finding, and it doesn't seem like the end is anywhere in sight. Whenever we look at the universe through the deep eyes of the Webb Telescope, we are taken on a quick ride to the early days of the universe instead of the edge of the universe. The bounty of information uncovered by the JWST has had scientists thinking about how far into the universe we can see. They have begun to fantasize about if we would ever see what the first moment of our universe looked like. This fantasy is at loggerheads with Albert Einstein's opinion that we would never see the first moment of our universe. According to Einstein, this period in the universe's history is so complex that it would shatter all the foundational pillars of physics, such as gravity, quantum mechanics, nuclear physics, and classical physics. He believed that these vital elements of our physics would collapse if we ever discovered the first moment of our universe. Einstein's words are coming to look like prophecy because the discoveries made by the Webb Telescope have left scientists more confused than ever. They have been forced to revisit notes and look up all the theories of physics, nitpicking at each part because these theories don't add up anymore. Scientists have been saddled with a headache that refuses to disappear as they keep comparing the results of these findings with current cosmological models. Despite all the efforts of astronomers to get an angle that links these discoveries with our known cosmological models, it's been a futile affair. Thus, scientists are starting to settle for the dawning reality. We might have to do away with our current cosmological models and establish new ones in the coming days. Astronomers were still trying to come to terms with this new reality when the JWST shoved another mind-blowing discovery at them. Before now, the Webb Telescope's searchlight had been moving around the early universe, poking at the early galaxies and their stars, and sending this observed data back to the ground support team on Earth. However, little did scientists know that as the Webb Telescope advanced in its search, we were just steps away from unlocking another history-shattering finding about our universe. The Webb Telescope recently discovered something astonishing, an early black hole that may be older than the universe itself. How can this be possible? Scientists have asked themselves. The news has generated a whirlwind in astronomy, and astronomers fear that our physics might not recover from this moment. According to a report by astronomers, it is the most distant black hole ever found. Upon close observation, we discovered it is nearly 500 million years old after the Big Bang. Thus, it has entered the annals of history as the most ancient black hole ever discovered. To understand the magnitude of this discovery, let's do a quick recap on the Big Bang. Our universe is believed to have been birthed by the Big Bang, which was an initial state of high density and temperature. So far, the Big Bang is the only theory that has stood the test of time in explaining how our universe emerged from nothing. In the Big Bang story, the birth emerged from a minuscule point approximately 13.8 billion years ago. This singularity was birthed from a state of perfect equilibrium due to a tiny irregularity, and it slowly evolved into the universe as we know it. Although this story looks short from where we stand today, it is a long one with different stages and billions of years in between. We are constantly reminded about this interesting historical event by the remnants of the original point that can still be found in black holes in our universe. Scientists believe the early universe, shortly after the Big Bang, was a scorching, dense mix of particles and radiation expanding at an alarming rate. During this period, there was no conventional light as we know it, because photons, the fundamental particles of light, consistently interacted with dense free protons and electrons, unable to move through space freely. Thus, it took 380,000 years after the Big Bang for the universe to cool down enough to allow the formation of the first neutral atoms, primarily hydrogen and helium. As the cooling progressed, photons could move freely, giving rise to the cosmic microwave background. Nevertheless, the universe was in perpetual darkness as there were no light sources like stars and galaxies. Several hundred million years after the Big Bang, the reionization process commenced with the formation of the first stars and galaxies. These young, Hot stars emitted intense ultraviolet radiation, which ionized the surrounding neutral hydrogen atoms. This ionization process splits the hydrogen atoms into protons and free electrons, making the universe increasingly permeable to ultraviolet and visible light. The formation of the first stars and galaxies was initiated by gravity-condensing gas clouds, particularly hydrogen and helium. However, a sneak peek at these condensed regions would reveal how the pressure and temperature increased to the point where nuclear fusion ignited in the course of these first stars, generating light and illuminating the universe for the first time. The radiance birthed from this process significantly contributed to the reionization process, gradually making the universe more transparent. The radiation from these stars and galaxies was potent enough to ionize the dense fog of neutral hydrogen that had pervaded the universe until that point. This ongoing process continued undisturbed until the entire intergalactic medium was predominantly ionized, signifying the end of the dark ages in the universe. It is at this junction that we draw the curtain on this story. Let's return to the black hole that has mesmerized scientists since its discovery. As astronomers studied this early black hole, it didn't take long for their hearts to start racing because of the shocking revelations they were uncovering. Like the early galaxies discovered by the Webb Telescope, this black hole had unusual properties that made it distinct from other black holes uncovered in the past. The data provided by Webb shows that the black hole is experiencing rapid growth a few million years after the Big Bang. This unusual growth has caused scientists to worry because it was not meant to happen. If we are to go by what is written in the books, this growth is impossible. From what scientists tell us, this black hole is 10 million times more massive than our Sun, which makes it a supermassive black hole by current standards. Nevertheless, scientists believe that this black hole would have required an external boost for it to get so big. However, the identity of this external powerhouse remains unknown, and this is one puzzle that scientists hope the JWST will solve in the future. From all indications, this black hole appears older than our universe, and scientists are having a hard time settling for this realization. Astronomers can't shake off the feeling that we have been confronted with a supermassive black hole that should have taken about 1 billion years to grow if we go by current models. How did such a black hole grow to this level less than 500 million years after the Big Bang? Based on research, it is 200 million years older than any known black hole. This is a considerable age gap. According to Roberto Maiolino, a researcher at Cambridge University, it is too early in the universe to see a black hole of this magnitude. So, we have to start considering other options and answer the question of how it was formed. Maiolino led the team of scientists who observed this black hole for weeks. Another interesting revelation that was unlocked from observing this black hole is that it was found in an ancient galaxy. Ordinarily, discovering the black hole inside a galaxy shouldn't come as a surprise. However, scientists weren't prepared for what they saw when they decided to dig further. The black hole, which was holed up inside the ancient galaxy called GNZ11, is eating up this galaxy. Astronomers were shocked to see the black hole clawing away at this ancient galaxy, devouring it bit by bit and 5 times faster than other black holes of the same caliber. This has caused the galaxy to be about 100 times smaller than the Milky Way. Scientists have attempted to picture how the galaxy might have looked before the black hole started consuming its material. It might have been the envy of other galaxies if it hadn't fallen prey to this parasitic black hole. What happens when a black hole eats up a galaxy? Well, when a black hole like this one consumes too much gas, it pushes the air away like an ultra-fast wind, resulting in a halt of star formation. When the galaxy gets to this stage, it is only a matter of time before it dies. However, the galaxy wouldn't be going alone, as the black hole would also die because the galaxy is its source of fuel. Like every other black hole, the gravitational forces exerted inside this black hole are so strong that they tend towards infinity, giving our measurement techniques a difficult assignment to solve. In all the new knowledge about this black hole, it is essential to point out that it is very far away from the Earth, about 13.4 billion light-years away. In literal terms, it would take 13.4 billion years for the light around the black hole to reach the Earth. Thus, whatever the JWST is showing us now is a scene from that long ago. Therefore, it is impossible to know how long the mass and its host galaxy lasted. This is one answer researchers hoped we could have answered. Nevertheless, as much as we try to shake off the fact, a new picture of the black hole is staring us in the face. We have no choice but to accept it and expand our understanding of the black hole phenomenon and, more importantly, of our universe. Initially, we only had a faint idea of how galaxies were formed and how the first stars were birthed. Over the years, our perception of this period in the universe's history has grown little by little till we had a decent picture we could show the public. However, scientists' happiness about this feat was still pegged at a certain level because we had yet to unravel what happened before the first stars and galaxies were formed. Something must have happened before the stars and galaxies came along. But as much as astronomers tried, this nut has refused to crack open. However, the Webb Telescope seems to be making progress in this direction, especially with the discovery of a black hole that appears to be older than the universe itself. According to the Standard Model, after the Big Bang, our universe became completely dark. Since we cannot see what happened in those dark ages, we don't have any story to tell because telescopes can't conjure observations from a period plagued by thick darkness. The universe wasn't transparent during this period, so our telescopes, including the almighty JWST, are almost helpless in this situation. However, scientists are beginning to entertain the possibility that our universe doesn't have a beginning. This rising school of thought is based on the premise that we aren't sure of what happened before the Dark Ages. We have been armed with incomplete observations, so it's only fair to believe that our universe might not have had a beginning. Astronomers have realized that there are many possibilities of what the universe might have been before the Dark Ages. That period can be likened to a blank check where anything can be written on it. This fast-growing perspective has presented scientists with a new challenge. If we say that the universe has no beginning, then how far into the early universe can the JWST see? Some astronomers have tried to answer this question by stating that if the Webb Telescope can see more of the distant universe than it is capable of, then after a certain distance, it will not be able to see anything in the early universe. If our universe has no beginning, we are on the verge of discovering emptiness if we probe beyond a certain distance in the early universe. Furthermore, scientists have reminded us of the possibility that the Webb Telescope may see objects that are not from our universe. The possibility of this event has excited scientists because it means we may stumble upon evidence that the multiverse exists. This explains why some astronomers are hard at work examining the evidence uncovered by the JWST. They are optimistic that if we remain relentless in our study of black holes, we might discover what exists at the other end of the abyss. They are hoping we'll find something like a parallel universe. While some are focused on that possibility, others are leveraging the evidence provided by this surprising black hole to piece together an acceptable narrative of how the first black holes were formed in the universe. This area has been a subject of ongoing research and exploration. With the successes that the James Webb Telescope has achieved so far, we can be assured that it is only a matter of time before this puzzle enters its list of solved mysteries. Thanks for watching this video till the end. For more captivating space discoveries like this, click the next video on your screen.